Hello and welcome. Today we are going to talk about a very simple design pattern called the proxy design pattern. Let's take a look at its definition. As per Wikipedia, a proxy in its most general form is a class functioning as an interface to something else. A design pattern that uses a proxy is called the proxy design pattern. Let's take a look at it with an example. When you think of proxy, think of a middleman who delegates work. So that proxy does some extra work and at the same time sits between the client and the service. Here is an example. Let's assume we have 3 players in this interaction: the client, the proxy, and the person who services requests from the client. And that person in this example is the real subject. Any request that goes from the client to the proxy is routed to the real subject. The real subject processes the request, sends the response to the proxy, and the proxy returns the response to the client. How is this beneficial? Before we get into the details of why we need a proxy, let's take a look at the class diagram. We have a client class, we have the real subject, and we have a proxy sitting in between the client and the real subject. The completed class diagram is we have an abstract subject which defines the contract implemented by both proxy and the real subject. So these two objects become interchangeable for the client, which is sitting on the left hand side in this diagram. The client class invokes methods on the proxy even though it's not directly dependent on the proxy. The proxy routes the request to the real subject that processes it. The real subject sends its response back to the proxy, and the response goes back to the client class. Any software is nothing more than an interaction of a bunch of objects, especially we are talking about object-oriented software. And in this interaction, we have a client and a service all the time, which is the client class and the real subject. When we introduce a proxy that intercepts calls between the client and the service and adds additional functionality, such a class is called a proxy. Let's go back to the original topic of why do we need proxy? The first reason is what is known as a remote proxy, which handles remote method calls because making a remote method invocation is complex. And we are going to take an example of that shortly. Another reason, we have a virtual proxy, which defers the creation of a real subject because the creation of the real subject is costly. Third reason, you have a protection proxy which protects the real subject from clients that do not have authorized access. There are other reasons where proxies can be used. Any proxy that implements additional business rules before and after a method invocation is made from the client to the real subject is an example of a smart proxy or a smart reference. There are plenty of examples of this on the internet, but proxies do add a lot of functionality in addition to just routing calls. And that's what I want to explain in the next several slides. This is case study 1. So in this example, we are going to take a look at a remote proxy. We have a client object, remote proxy, and real subject. The real subject is a service that resides in a totally different address space, different from the client and the remote proxy. It could be a web service object. It could be anything which requires a remote method invocation. And the remote proxy acts as a local object to the client. So in this example, the real subject is residing in a remote address space, and the client sends a request to the remote proxy. This method invocation appears like a local method call. The remote proxy, in conjunction with the runtime, takes care of all the low-level plumbing, such as building an HTTP request or serializing or deserializing objects and other stuff, and sends that request to the remote real subject. The real subject processes data and sends the response back to the remote proxy, which again takes care of the serialization, deserialization of objects and communication protocols. And this is not completely done by remote proxy. It works with the installed runtime and the server to do that, but it takes care of all the hard work here, and the response is returned to the client. So this is where the value of remote proxy is. All the details of remote method call, serialization, deserialization, building HTTP request, response, SOAP message encoding, all that is done by the remote proxy in conjunction or with the assistance of the web server and the runtime. So here I have a Visual Studio solution with just one project, which is a console project. And this is not a tutorial or a demo on how to call UPS API, but I just wanted to provide an example of how a remote proxy is created in Visual Studio. So we're going to right click on the service reference, add service reference, and I have the WSDL file for the UPS XML address validation service downloaded somewhere. I just point to that WSDL file, click go, and in the namespace, as you can see in the service, I see the XAV service which is present, and it has got an XAV port type and a bunch of other stuff. And here I'm going to call it XAV demo service, or actually I'll just call it XAV demo client, and my XAV demo client is created. And as you can see, Visual Studio creates a bunch of classes. One of the class that is under reference.cs, if you scroll down, it's called the XAV port type client, and this is the class. It's a partial class, it's auto-generated, and it's got a bunch of stuff here, reads configurations and does good stuff for us. And if I look at the web config or the app config file for this solution, I have got a setting that points to this URL, which is the URL of the UPS site. It's actually their testing site. And now I can go back to the program.cs and add some basic code. I'm not going to show a finished product here in the code, but essentially what we are doing is we are adding a remote proxy. So here we call XAV port type client, and that is equal to XAV port type client, and I'm going to just call on the client process XAV. By the way, XAV stands for XML address validation. And then I'm going to pass two parameters here. I'm just going to pass null for the time being, and the response is what will be the response from the address validation service. I'm going to create the two input parameters. Those are UPS security and XAV request. So UPS security, which I'm going to call as parm1 equals new UPS security, and XAV request parm2 equals new XAV request, and then I'm just going to pass parm1 and parm2. So what did just happen here? We added a service reference which created a proxy class which is called as XAV port type client does a bunch of stuff, but to our program, which is program.cs, all we are doing is we are just calling the client, which is our remote proxy, and we're passing the parameters and we are invoking methods as if XAV port type client were a local object, and the UPS service is at least appearing like a local object because we are able to call process XAV on the remote proxy. However, behind the scenes, the client class, the remote proxy, routes our requests to the UPS service, which is hosted somewhere by UPS, definitely not in our network, somewhere else. And all this low-level plumbing of building HTTP requests, the SOAP headers, the SOAP envelopes, request and response, everything is handled by the .NET runtime or the web server at the other end. Let me show you how the fully completed code looks like. Their test system just accepts California and New York state addresses. So I'm just going to pass here a New York address, which is 11 Wall Street. It's in New York City, and I'm not going to provide a zip code, and it comes back and gives us the validated address with a full zip code of 10051905. This is the address of the New York Stock Exchange, and essentially what we have accomplished is we have implemented a remote proxy which does a lot of low-level plumbing for us. The code is all generated by Visual Studio, and we are able to successfully call the service. This code as is will not work. We'll have to do more initialization, and I will include my blog in the description of this video that will show how to invoke this code with all the details. But for this demo, we're just trying to understand how a remote proxy works. Here is case study 2, protection proxy. This is just a code snippet to keep things simple. In this example, we have the protection proxy code, which is invoking a method on the real subject, which is called the real subject. What it does is it checks the identity of the currently logged in user, and if the user is in the administrator's role, then invokes the method, otherwise throws the security exception back to the client. So in this example, the protection proxy is protecting the real subject from unauthorized access. This is case study 3, virtual proxy. Let's take a look at the code. This is the interface, iCustomer account, that is implemented by both virtual proxy and the real subject. This is the real subject. It's called customer account, and it holds a list of all transactions that are associated with that customer account. So this is similar to a bank account where all the transactions, both debit and credit, are recorded against the customer account. In the constructor, when the customer account is created, this process involves a costly operation to load all transactions since the customer account was opened. The show balance method, which is what is required by the contract, loops through all the transactions associated with that customer account, sums up their amount, and then returns the balance. So that balance, which is the sum of all debit and credit transactions, is the balance on the account. Now, if we take a look at the virtual proxy, it holds a reference to the real subject, and it takes the customer ID as input in its constructor. But as you can see, it does not immediately create the real subject. It does not create it till the show balance method on the proxy is invoked, which is when it has to create the customer account and the process has to create and load all the transaction objects associated with the customer account, which is the real subject here. So the idea is when a client calls proxy, they're going to instantiate it with a customer account number 1234567 8 in this example, and then they could do some work, but in the end, when the client requests show balance or wants to know the balance, then the proxy will go ahead and create the real subject, and that way the costly operation of creating the real subject is postponed till the second last line shown in the sample. Thanks for watching this video. Hope you liked the information. Your feedback is always appreciated, and I hope to see you in another video. Thank you.